Hello, today we are covering medians and altitudes of triangles. By the end of today, you'll be able to identify and use both the medians and the altitudes. So our new vocab is median, centroid, altitude, and orthocenter. These are similar to our previous lesson, although these lines are slightly different. So we'll start with the median. A median of a triangle is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. Every triangle has three medians that are concurrent. That means the point of concurrency is where they all meet up. So it'd be like right about there in this triangle. This point of concurrency is called the centroid and is always inside the triangle. I would underline that. That's a good always, sometimes never type question. So if you notice, the median creates congruent segments because D is the midpoint. So we have the centroid theorem. This states the medians of a triangle intersect at a point called the centroid that is 2/3 the distance from each vertex to the midpoint of the opposite side. So first of all, I want to point out these are all midpoints, L, K, and J. So the segments that it forms are congruent pairs. So that's important to know for the centroids. It's their medians. Then we know that these segments, so take AK, this whole segment, if we take 2/3 of that segment, we know the length from the vertex to the centroid is 2/3 of that. Then we also know, based on that, that PK has to equal 1/3 of the whole segment, because that's all that's left to be available. So let's try some. We are given the triangle XYZ. We know P is the centroid, meaning we could mark these all out if we wanted to. So P is the centroid, and YV is equal to 12. Then we want to find YP and PV. So if we know the whole thing is 12, we can set up our equation. YP is equal to 2/3 the whole thing, 12, and solve. So we get 24/3 is equal to 8, so YP equals 8. Okay, now there are 3 different ways you could actually solve for PV. We can set up the secondary equation. PV is equal to 1/3 the whole thing, so that is 4. We can also know that the whole thing, 12 minus YP 8, has to equal 4, which is the leftover PV, still equals 4. Or you can use an extra shortcut where we know that because YP is 2/3 the whole thing and PV is 1/3, that means the longer vertex to centroid part is double the shorter centroid to side part. So we could do 8 divided by 2 and also get 4. Either of the 3 ways we do it, we always get PV equal to 4. The next one works very similar. We've got the triangle. We know R is the centroid. We know LO is 30. So I'm going to set up LR.
Louis Reeves, please report to lot C for driver's edge. Louis Reeves, please report to lot C for driver's edge.
LR is equal to 2/3 the whole thing, 30. So this is equal to 20. If we take 2 times 30, we get 60. Divide that by 3 and we get 20. So this segment LR is 20. I know RO must be half of that. So RO is 20 divided by 2. So RO is 10. And we are done with that one. These next 2 give us a little different information. Notice it doesn't state that these are centroids, but we know they are because we have marked out these congruent pairs. So we know this is the centroid, so we can use our 2/3 idea. G is the centroid. Notice we don't have all of them having 90s. If they were 90s, we'd have to go back and revert to our circumcenter idea. But because they aren't marked as 90s and they're marked as just medians, we've got our centroids. So this time we are given CG is equal to 4. We need to find GE as well as the whole segment. So simple enough, we know CG has to be double GE. So we take CG is equal to 4, we divide that by 2. So if CG is equal to 4 divided by 2 is going to equal GE. So GE equals 2. Now we can say the whole thing is equal to those two added. So CE is equal to 6 because we take 4 plus 2 and equal that to 6. If you prefer equations over what we just did, you could also set up an equation based on our original equation. We have 4 now is equal to 2/3 the whole thing CE. To get CE by itself, you multiply by 3/2 on both sides, and you end up getting 6 equals CE. Notice these are the same. Then you can just go ahead and solve for GE from there. And this one, once again, super similar. JP is 16. We want to find the shorter segment as well as the whole thing. I'm going to do it the first shortcut way that I did before as well. So I know PM is half of 16 because it is between the centroid and the side. That means it's the shorter segment, so it's half of that. So PM is 8. And then I just add 8 plus 16, and I get JM is equal to 24. And I'm good to go. Now, if I'm going to try to find the coordinate of the centroid, I'm going to start by plotting these points. 1, 4, 3, 0, and 3, 8. We got pretty lucky here because we have a vertical line. That makes it easier to solve these. I'm also going to write in what these are. So we start out, I'm going to find the midpoints of all these because I know my centroids are made up of midpoints on the opposite sides. The vertical one's pretty easy. I just count. It was 8, so I go 4. I have my midpoint. The other ones are a little more difficult. I'm going to use the midpoint equation. So I take my x's and average them. And I take my y's and I average them. And I end up getting 2, 6. Check it, make sure that actually does work. It should cross on the triangle. If it doesn't, something's wrong. Good to go there. Do the same thing with the other 2 pairs of points. So we have 2, 2. Check that that works again. I just found the midpoint. You can pause if you need a little more time to work through that. And then I'm going to connect these with my medians. These should all cross at the same point. Notice they do. Our goal is to find that point of intersection of the centroid. So once again, we get lucky because now we have a horizontal line here. We know the distance of that line is 2. So I can use my equation to find the length from these points here. So from the vertex of the triangle to the centroid, I need to find that distance. So I'm going to just do a random variable. Let's say z is equal to 2/3 of 2 because that's the distance of that whole segment. So z is 4/3. This is z right here. So if z is 4/3, I actually need the full distance over here, which means we start at the vertex over 1, which means I need to add 1 to 4/3 to get to that centroid part. So I'm not just going over 4/3, I'm going over 1 plus 4/3. So 1 is equivalent to 3/3. So that is 7/3. So that's my x value here. And my y value, once again, we got really lucky. We're going to count up 1, 2, 3, 4. And we are good to go. So if you check here, 7/3 is actually 2 1/3. Make sure you go over 2 1/3 and up 4. If that is looking good, which it does to me, that is the point of our centroid. So that is where all 3 lines cross. Okay. We have another one. I'm just going to work through it. You can follow along. It's going to follow exactly the same as the other one, just there will be one part that's slightly different. So all I've done so far is graph them and label the coordinates. Now I'm going to find all my midpoints. Okay, so I found my midpoints, connect with the medians from the vertex to those midpoints. They should all cross at the same spot. If they don't, it's probably just human error. They all do though, so thankfully that's pretty nice. So that is the point I'm trying to find. Once again, notice that the distance there is 2. So we're going to do something very similar, but this time we're actually trying to find the distance. It's kind of hard to see. We'll zoom in. We're actually trying to find the distance from the axis to this point right here. So we are going to use from the side to the centroid as our reference this time. Meaning we want to say, I'll say z again, is equal to 1/3, and not 2/3 because it's side to centroid, 1/3 of 2. Okay? So that is 2/3 z. But notice once again, we actually have to travel all the way back here, so we need to add 1 again, which is the same as 3/3, so that's 5/3. So that's my x value. But notice we move in the negative direction. So we've kind of been doing distance, absolute value type, so it's actually negative 5/3. And then we go up, we got lucky, it's on a pretty point for the y value, we just go up 2. Make sure that actually checks out. To me, it sure does, so we are good to go. Negative 5/3, comma 2 is our centroid point. Now we have altitude, so we're moving from centroids and medians to altitudes. An altitude of a triangle is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. An altitude can lie in the interior, exterior, or on the side of a triangle. So basically, an altitude is anywhere on a triangle, it can't even be coming this way, that drops down from a vertex. So that wasn't a very good example. From the vertex to the opposite side at 90 degrees. I still don't like that very much. My pen's not doing a very good job, but like that, okay? So it comes down, drops to 90. So if it's an acute triangle, most of the time the altitude will drop inside the triangle. This obtuse triangle, it drops outside the triangle. Notice it comes down, comes to 90, so we're actually extending outside the triangle. Altitudes just drop from a vertex to the opposite side at 90 degrees. We'll use that a lot when we get to areas. And from there, we have the orthocenter. There isn't super anything interesting about the orthocenter other than they all do cross at a concurrent point. So the lines containing the altitudes of a triangle are concurrent, intersecting at a point called the orthocenter. We don't have any like cool equals or 2/3 or
Joe
anything.
Landis, please come to the front office. Joe Landis.
But it does exist. And then this last slide, probably one of the most helpful slides we have just a table, kind of cheat sheet, for what each of these does. So perpendicular bisector, notice it comes in at 90 and it cuts it in half. That has to do with the circumcenter, and it tells us what is congruent. So from the circumcenter out to the vertexes are congruent. Then we have the angle bisector. That's where the angles are congruent. This is called the incenter when we have all three of them. And then from the incenter out to the sides are congruent. We also have the median, where it comes from a vertex and then straight down, or comes from the vertex and then makes a midpoint on the opposite side, creating two congruent segments. That's the centroid, and we have the 2/3 idea. And then we have our altitude, which creates the orthocenter. Nothing super special there, but it does exist. And that's all for today. Have a great afternoon.